In this video, we're going to talk about volume thermal expansion. Let's have a look at the word problem written here. It says here, a glass flask with a volume of 200 cubic centimeters is filled to the brim with mercury at 20 degrees Celsius. When the temperature of the system is raised to 100 degrees Celsius, does the mercury overflow? I'll give you an example of what's happening here. We have a glass flask. Here is sort of a glass flask. It's a test tube, and it's made of glass. And if I were to heat this up, the volume inside that is holding that this test tube can hold, right now it's just filled with air. The volume inside will also expand. The entire glass will expand. If I heat this up, it will expand in all dimensions, lengthwise, widthwise, heightwise, and such that the entire volume on the inside, the entire volume will also expand. So this whole thing just basically is going to expand. Here's my glass flask. And I could look at this another way as well. Let's just put this back on. Here's a container, stainless steel. And I can measure the volume of this in the inside. And if I were to heat this, it will expand in all directions. Volume-wise, it'll expand all that way. It can expand height-wise, width-wise, lengthwise, such that the inside here, the volume, the amount that it can hold, well, it will be able to hold more. If I heat this up, it's going to expand. And if I put a liquid in here and I fill all that liquid right up to the very brim, right up to the very top here, and I heat everything together, the liquid inside as well as the steel flask itself, everything will expand. And the question is asking us, if this was filled with mercury, or in our case right here, it'll be the glass. If it's filled with mercury and we also have glass, when I heat this up, both will expand, the mercury as well as the glass. Will the mercury overflow? The answer is yes and no. If the mercury expands greater amount than the glass does, then it will overflow. If the mercury does not expand as much as the glass and the glass expands more, then the mercury won't overflow. So let's solve this problem and see which way we're going to go. Okay. And the question here, does the mercury overflow? So we're going to draw a picture of a glass flask, and I like to draw it like this. Here, it's a cauldron. Here's a cauldron, and it's got a little lip like so. And this cauldron here, this is the glass flask. And inside of this glass flask, we're going to fill it up with mercury, all the way to the very top with mercury, such that if I were to add one more drop of mercury here, one more drop, that drop of mercury will fall out here. So it's actually the very, very top. And we're going to heat this up. And I like to indicate heating up something here with a campfire. So here's a campfire, and it's sending up heat. And so the entire system is going to get heated, the glass as well as the mercury inside. These two items, the glass and the mercury, I'll just write here mercury. The glass and the mercury, they have two different thermal expansion rates. They're written here. Coefficient of volume expansion for glass is this term, and for mercury it's this term. And where do they come from? Well, do they come from a chart? Here's a chart. You can look these up in different charts, get different values based on the units. Looking at this one right here. Coefficient of volume expansion, that's what we're interested in. And we're interested in glass. And glass can vary between 1.2 to 2.7, 10 to the minus 5. And in this particular chart, the unit is given to us as Kelvin, per Kelvin. The term for beta is the coefficient of volume expansion. And we also have mercury. And here's the term for mercury, the value for volume expansion for mercury, in terms of Kelvin, per Kelvin. We could also look this up in other charts, such as this one. And this particular one right here has volume expansion in terms of Celsius degree. So here's common glass. Common glass would be 26, 10 to the minus 6 Celsius degree. And down here we also have mercury in terms of Celsius degree. But for our word problem, we're going to work with Kelvin, as we are using this specific term here in terms of Kelvin. So let's put this away and carry on with solving our problem. We need the equation. And this is the equation for volume thermal expansion, equation 29. I'm going to write that down. Change in volume is equal to beta. Beta we just talked about, it's the volume expansion, volume thermal expansion for glass and for mercury, beta. The initial volume times delta T. Now I spoke at length about delta T in a prior video, so I'm not going to concern too much with delta T. I'm just going to go ahead and expand it. So this can be changed to, change in volume is equal to beta initial volume times temperature final minus temperature initial. To solve this problem, we have to do this twice. Once for the glass flask and once for the mercury, and then compare the two answers. The change in volume answers right here. So we're going to start with the glass flask. So we're going to use this equation. I'm going to put a subscript here for the glass, for beta for the glass, the initial volume for the glass, and the temperature of the glass. Everything is going to be with respect to the glass. Write down a quick list of what is given with respect to the glass. The volume of the glass flask is given to us here as 200 cubic centimeters. That'll be the initial volume, VI, initial volume. And we have initial temperature at 20. That'll be a capital T for temperature is equal to 20 degrees Celsius. Final temperature is, we're going to raise this up to 100 Celsius. And beta for the glass is given to us here. The coefficient of volume expansion of the glass from that chart, as we saw, is going to be beta is equal to 1.2 times 10 to the minus 5. Kelvin to the minus 1 means it's divided by Kelvin, per Kelvin. And that's a 5. So we have everything we need, almost. Beta here is in terms of Kelvin, and our other temperatures are in terms of Celsius. So we need to change these to Kelvin, so everything here cancels out properly in terms of Kelvin. So 20 degrees Celsius, I'm going to add to it 273, and I'm going to ignore the 0.15. So degrees in Celsius plus 273 will give this value in Kelvin. That'll be 293 Kelvin. And if I were to add 273 to the 100, and I know that the absolute zero is minus 273.15. I'm just ignoring the decimal place and just going straight with the whole number. So 100 plus 273 is equal to 373 Kelvin. We have everything we need now. Put it into the equation. Change in volume is equal to beta 1.2 times 10 to the power minus 5 per Kelvin times the initial volume, 200 cubic centimeters, times the two temperatures. Temperature final in Kelvin is 373 minus 293, and that'll be a unit of Kelvin. Kelvin and the Kelvin cancel out, and that leaves me with this term here, in terms of cubic centimeters. Now this is not a base unit. Cubic meters would be the base unit, cubic meters. But there is no other units here. This is the only one left. Since this is the only one left, why change it? And that cubic centimeters, that is also known as milliliters. By definition, I'll write it over here. By definition, 1 cubic centimeter is equal to 1 milliliter. So this right here can also be 200 milliliters. They're the same, one and the same. And I know of no reason to want to change this to cubic meters because there are no other units in this equation. The 2 kelvins cancel out. That's the only one left. Therefore, the volume of this in the end will be left in terms of milliliters. So no point in doing the extra work. So what we're going to do here is simply follow the units. Time has come to start following the units. We still have to understand what base units are and use them when it's appropriate. But when we can get away with this and everything else cancels out, well, let's do it. Solving this then, change in volume, and this is for the glass, is equal to, when we do this multiplication, all of this across, the answer comes to 0.192, and the unit, I'm going to stay with milliliters. So the change in volume of the glass is 0.192 milliliters. We need to do the same thing now for the mercury that's inside. Okay. Let's draw a line here. And we're going to hold on to this number. I'm going to start over here on the left, doing the exact same thing. Change in volume now for the mercury is equal to beta of the mercury, the initial volume of the mercury, times temperature final minus temperature initial of the mercury. All of this is for mercury now. If I write down a list of what is given, the initial volume of the mercury, well, I'm going to fill this entire thing, this glass flask, with mercury right up to the very brim. The initial volume on the inside of the glass was 200 cubic centimeters. Therefore, the amount of mercury that's going to fill in here is also going to be 200 cubic centimeters or 200 milliliters. And I'll just stay with cubic centimeters. And the initial temperature, same as before, initial temperature is going to start at 20 degrees Celsius. And then we're going to have to add 273 to that. Make that 293 Kelvin. And the final temperature is going to go to 100 degrees Celsius. I mean, it's a system. The whole thing is going to heat up, the mercury inside as well as the glass, starting at 20 and everything's going to go to 100. So 100 Celsius plus 273 will give us 373 Kelvin. And one that's different is the coefficient of volume expansion for the mercury. That number, beta for the mercury, is 18 times 10 to the minus 5, and it's in terms of Kelvin per Kelvin. Putting this now into the expanded equation here, change in volume of the mercury is equal to beta of the mercury. It's 18 times 10 to the minus 5 per Kelvin, times the volume, 200, times temperature final minus temperature initial. Temperature final was 373 minus 293, and that will be in terms of Kelvin. The 2 kelvins cancel out, and we're back to where we were before with cubic centimeters or milliliters. 200 milliliters. So the change in volume of the mercury is equal to, using the calculator and calculating this value here, the answer is 2.88 milliliters. So the mercury will expand 2.88 milliliters in total volume-wise. and the glass flask will expand a value of 1.92. Therefore, the amount of overflow, clearly this is going to overflow because the mercury is going to expand more. The overflow is then going to be the 288 of mercury, or 2.88 milliliters mercury, minus the volume expansion of the glass flask, which was 0.192 milliliters. Subtracting these two, 2.88 minus 0.192, the overflow is equal to 2.688, and the unit is in milliliters. Rounding this to three significant figures, not taking into consideration that this is subtraction. I have 3 sig figs here, 3 sig figs here. We'll just go round this to 3. Therefore, overflow approximately 2.69 milliliters of mercury.